All right, let's take a closer look at lines. Those are the solution sets, remember, for linear equations of two variables. We're going to look at the intercepts. That is where the line crosses the x and y axis, if it does. And then we'll do an example, we'll graph, and then we'll take a look at some special forms of lines, particularly horizontal lines and vertical lines. So let's start with the intercepts. There are two possible intercepts for a line. It could cross the x-axis, in which case we'd call it an x-intercept. It could also intersect the y-axis, in which case we would call it a y-intercept. And recall the x and the y-axis look like this. So we have the x-axis is the horizontal, usually represented by x, variable x, and the y-axis is the vertical direction, represented by the variable y. Okay, now, if a line were to intersect the x-axis, right, we would know something about it, or we'd know something about that point, rather. So points that intersect the x-axis all have something in common. Can you see what that is? All these points have something in common. Well, notice that their vertical component, right, in terms of up and down, is 0. Right? They lie on the axis. So all x-intercepts are going to have the form some number for x and then 0 for y, always. So the x-intercept is going to be a point. We'll call it a comma 0. And this is a point where the line intersects the x-axis. How would we find that? Well, since we know all the points have a component, y component of 0, we will take our linear equation of two variables and put in y equal to 0. We'll set y equal to 0, and if we do that, we'll be left with an equation of one variable in x. Solving that will give us the x component for the x-intercept. So to find x-intercepts, we set y equal to 0 because all of the points that are x-intercepts have a y value of 0. And then we solve for x to get the x component. Where does it hit the x-axis? That x value tells us. All right, y-intercept, that's where the line crosses the y-axis, and you can see something in common about all of those points as well. On the vertical axis here, the x-coordinate is always 0. We're not to the right, not to the left, we're on the axis, and so the y-intercepts will always have the form 0 comma some number, we'll call it b. So 0 in x and b in y. And to find y-intercepts, very similar to the x-intercept, we know that all the points that are on the y-axis have an x component of 0. So we'll set x equal to 0 in our equation and solve for y. All right, let's go ahead and do this, find the x-intercepts and y-intercepts for a linear equation of two variables. We'll also then use those intercepts to graph. If we have the intercepts, it's more easily graphed. So here we go. So we've got 4 minus 2y equals negative 2 minus 6x. All right. This is a linear equation, two variables. We see the y here, we see the x here, and nothing else going on other than this negative 2 and 4. And now what we want to do is find the intercepts. So we'll start with the x-intercept. We'll set y equal to 0 and solve for x. So we'll start with the x-intercept. And I'm just going to write down what we're going to do. We're going to set y equal to 0. All right, so we have 4 minus 2 times 0 equals negative 2 minus 6x. Okay, this negative 2 times 0, this goes away. We're left with 4 equals negative 2 minus 6x. Add the 2, we get 6 equals negative 6x. And then we can divide by negative 6. So we get x equals negative 1. All right, so the x-intercept is going to be the point negative 1, 0. All right, now since I know we're going to graph this, I'm going to go ahead and plot negative 1, 0. So here I'm at 0, go 1 to the left, and I'll put a dot right there for 0, or the x-intercept. Okay, so that's the x-intercept. Go ahead and pause the video right now and find the y-intercept. So when you do that, you're going to set x equal to 0 and solve for y. Okay, so what did you get for the y-intercept? So we set x equal to 0 and solve for y. So this term goes away. You can subtract the 4. You get negative 2y equals minus 6. And so the y-intercept is going to be, looks like 3. Right, so yeah, so x 3, subtract, divide, yeah. 0, 3. All right, so we'll plot that as well. So 0 and x, 3 and y. So we go up 1, 2, 3, dot there. All right, and now we have 2 points, so negative 1, 0, and 0, 3. And we can then plot the graph of the line. And if you have a straight edge, you should use that on paper. So set that up. And draw the graph. Make sure it goes through those 2 points. Long enough to fill up the graph. And since lines extend infinitely, either direction, we'll want to put arrows on those. All right. So we have x-intercepts and y-intercepts. We know how to solve for those. And we can also use them to find the graph, to graph the line. All right. There's 2 more things I'd like to talk about, and those are horizontal and vertical lines. All right, so let's take a look at horizontal lines first. So horizontal lines all have the same form. Let's just draw one. Okay, so there's a horizontal line. Notice it does not rise or fall any. In that case, all the points are going to have kind of a similar characteristic to all the points on the y-axis, or I'm sorry, on the x-axis. All the points on the x-axis have a y value of 0. All the points on a horizontal line will have the same y value. It might not be 0, it'll be something else. Right? So all of these points along here, all of them would be of the form, since this is negative 2, this would be of the form, so the x could be anything. So when we have some number for x, so a comma negative 2 in the y component, right? And so we usually write that in this form. So x equals, y equals. The x can be anything. Right? There's no restriction on the x. You can have x equal to 1,000, x equals to negative 1,000, anything in between and beyond that. But what we want to do is say y. Y is locked down. Y has to be something like this. So y equals negative 2. Right? Now typically, it may not be negative 2. It could be any number there, depending on what the horizontal line looks like. So the general form here is just y equals b. You might have some coefficient on the y. We can always divide that over to write it like this. Okay. We have vertical lines. And let's draw a vertical line. All right. Okay, so vertical lines, just like this. So all the points are going to have the same x component, but it could be any y. So in this case, we're at, let's see, 1, 2, 3, 4. So this would have equation x equals 4. Yeah, x component is always 4. The y value could be whatever. Right? Put the y equals -2 on here. Okay, so we'd write the equation just like this, x equals 4. In general, we'd say x equals some number. I'll just call it a. X equals a would then represent the equation, or the vertical line. So this is how you can identify from an equation like this, where the line is not vertical or horizontal. The x and y will both appear. If one of the x or y's are missing, you know you're going to have either a horizontal or vertical line. Y equals b gives you a horizontal, and x equals a gives you a vertical.